Alright, how are you again? Let us look at polar coordinates. The polar coordinate. Now, what is the polar coordinate? Let's say you are given a double integral in terms of x and y with some particular differential dx dy or dy dx. Polar coordinate will change the integral to f of r is to theta r dr d theta, where this integral is the theta integral, where this integral is the r integral. Right, we are changing an integral from f of xy to r and theta. Now, this r here is called the Jacobian. The Jacobian. They call the Jacobian. You're always going to include it whenever you're converting from rectangular coordinate to polar coordinate. So what you need to know here, we are working with cycles. We are working with cycles here. Right, we are working with a cycle, with cycles, different kind. Now we are going to have quarters, halves, different kinds of halves. We are only going to focus on that. We are not going to focus on other things. Another thing that you need to note is that our cycles that we are working with are centered at the origin. We are working with cycles which are centered at the origin. Right. Now, basics. If you have x squared plus y squared is equals to r squared, this is the equation of a cycle. Right? And we always change x squared plus y squared to r squared. So what does it mean? You see something like this, change it to that, because our integral only have r and theta. So whenever you have x squared plus y squared, change it to s squared. Let us look at an example. Now, if you have a 2x squared plus 2y squared, this thing is the same as 2 in bracket x squared plus y squared, which is the same thing as 2r, right? 2r squared. Same thing as if you have a negative 4x squared minus 4y squared. This can only be a negative 4 in bracket x squared plus y squared, and it's going to be negative 4 r squared. You need to remember these two. Whenever you have something like this, change it to r, right? Change it to r. But negative 4x squared plus 4y squared will not change to either negative 4r squared or positive 4r squared. The reason being is because the sign of this 4 is different to the sign of this 4. They must be the same. Negative, negative, positive, positive. If you have a negative and a positive, that thing does not change. Right, now you understand that x squared plus y squared is equals to r squared is an equation of a cycle. Right, we'll be back. And also, x is equals to r cos theta. So whenever you say an x in your problem, change it to r cos theta, and y is just r sine theta. Now, if you square both of these and add them, I'm going to have r. So I'm not going to prove that. You can prove it in your free time, or you can check it. Right. Now, what you need to know again is the value of theta. Now, the value of theta. Right. Your theta is measured from 0, pi over 2, pi, 3 pi over 2, or negative pi over 2 to 2 pi. So we're measuring this theta from here. You're moving anti-clockwise. Right. What you need to know about theta, your theta measure, how do you write measure? Measure the region from its starting point to end point. Right. And if there is a line in the region, theta will always start at theta is equal to the arctangent of m. We will talk about this. We'll talk about this. But now you know that theta is from 0, pi over 2 pi, 3 pi over 2, negative pi over 2 pi. You always move in that order. 0, pi over 2 pi, 3 pi over 2 to negative pi over 2. We always move in that order. Right. Another thing that you need to know about is the cycles. Now, a full cycle. Now, if I draw a full cycle in your Cartesian plane, it is something like this. It is something like this. Right. Now, a full cycle will always have the value of theta to be 0 to 2 pi. It's given by x squared plus y squared is equals to r squared. And your theta will range from 0 to r. Keep in mind that r is the distance from the origin to the outermost part of the region. So that one will be r. So whenever you're integrating over a full cycle, these are the bounds. Now, half cycles. Now, if you have y is equals to r squared minus x squared, and there is a square root here, your region, it is something like this. That is your region. This thing means I am a positive semi-cycle, right? So your theta will range from 0 to pi. Your theta will start here and move until it goes there, which is pi. And then your theta is going to start from 0 to r again, a positive half semi-cycle. And then if you have x is equals to square root r squared minus y squared, you actually have this thing here, this side. So your theta will start from 3 pi over 2, because we are moving from here. We are always moving anti-clockwise from here to up there, which starts from 3 pi over 2 to pi over 2. Or your thing will start from 0 to pi. Now why I'm saying this, it is because if you rotate this diagram about 180 degrees or about 90 degrees, you are going to have this picture above. So your theta will not matter anyway, will not matter. And then your r will start from 0 to r, like that. Your r will range in that. So these are positive semicircles, right? And then what if we have negative semicircles, right? Negative semicircles. Now what do we mean by having a negative semicircle? We mean that we are going to have y is equals to minus the square root of r squared minus x squared. So your diagram that you are going to see is something that comes here to there. So it's the below graph. Your region start here to there. Now your theta will range from pi to 2 pi. Or your theta may range from 0 to pi. It does not matter really, guys. It does not really matter. And then your r, it's still from 0 to r. And then if you have y is equals to minus the square root of r squared minus y squared, I'm going to have a region like this. Here, like that. In this case, your theta will start from pi over 2 to 3 pi over 2, and your r is still from 0 to r. Your r will always start from the origin to the outermost. Your r will always start from the origin to the outermost point. Your r will always start from the region to the outermost point. So now you ought to, for sure, you understand the picture of the polar coordinate. So you're changing from XYZ to polar coordinate. Now let us look at examples. Maybe if we look at the examples, you will get a feel on what we are doing, right? Number 1, let us integrate 0 to 2 and 0 to the square root of 4 minus x squared, and then I'm going to have here x squared plus y squared dy dx. Now how would I integrate this in terms of y? What I need to do, I need to draw the region for this. I will need to draw the region for this. Right. Now drawing the region for this, you will notice that if you take out the things, I'm going to have x is equals to 0, x is equals to 2, and then y is equals to 0, and y is equals to the square root of 4. Square root of 4 minus x squared. Square root of 4 minus x squared. So if you draw the graph, now we have y is equals to 0, which is the x-axis, right? So that is y is equals to 0. And then we have y is equal to square root 4, and it's positive, so it's a positive semicircle. So if we draw the region, I'm going to have something like this. Right, I'm going to have something like that. Right, something like this. And the next one is that I need to have x is equals to 0. So x is equals to 0, it's this line here. And then x is equals to 2, it is this line here. Now when you think about this, which one is the region? Is this R1? It's this R1 or it's this R2? Now think about it. Is this R1 or is it R2? It is R2 because R2 is bounded by this graph here and that graph there. So what is going to happen? I'm just going to erase this part. So that is your region because it's bounded by the most functions. Now if you substitute the angles in, your region starts here at 0 to pi over 2. So but now we do have x squared plus y squared. When you see x squared plus y squared, we change it to r squared times. When we change dy dx, it's going to be r squared dr. It's not going to be r squared. It's going to be r dr d theta. We always going to include this r. We always going to include that r. Right? And the next thing that you need to notice is that the last integral, it's d theta, and your theta start from 0, start here and move in this direction. So it's 0 to pi over 2. 0 to pi over 2. And your r starts at the origin to the outermost function, which is 0 to 2. Now this number here, the last integral always resemble r. Now you can integrate this, and the way we integrate this is very fun because the first integral or the entire integral only has constants on it. Because the entire integral only has constants, what we need to do, we need to just group the integrals with their differentials. So I'm going to have something like this. An integral from 0 to 2 pi, not 2 pi, pi over 2 d theta times an integral from 0 to 2 r cubed dr. So I'm going to have pi over 2 if you integrate that, and then I'm going to have 1 over 4, so it's going to be 4, like that. And I'm going to have 2 pi as this thing, because what you did, we just grouped this one, we just grouped the last integral with the differential, this integral with that, and we integrate here, we integrate there, multiply the two answers, I am going to have that. Right, so let's look at another example. From -2 to 2, let me just do with 1, -1 to 1, square root 0, square root 0, 1 minus x squared, e to the power minus 4 x squared minus 4y squared dy dx. So to integrate this first, we need to take out our equations are called. So it's going to be x is equals to -1 and x is equals to 1, right, from the last integral. And then for y is equals to 0 and y is equals to the square root of 1 minus x squared. So what we need to do next, we need to draw the region. When we draw the region, right, Now the first one, it is y is equals to 0. Y is equals to 0. It is a line here. It is a line which is horizontal. Right, and then y is equals to that. It's just this curve. It's just that curve. Right, it's just that curve. Right, having a turning point of 1 there, which is 0 is to 1. Right. The next one is x is equals to minus 1. X is equals to minus 1. X is equals to minus 1, and x is equals to 2. X is equals to 1. So your region that you are talking about, we're talking about the entire region here. Now changing this integral to polar coordinate, it's the simple thing that you need to do. A double integral. Now your region starts from 0 and goes and pass pi over 2 and ends at pi over pi. Right, because here it's pi over 2. And your r will start here and goes there, and which is r is equals to 1. So your theta start from 0 to pi, and your r will start from 0 to 1. Right, and then remember, now we have a negative 4x squared minus 4y squared, and we know this is going to be a negative 4r squared, because we're going to factor out your negative 4 and have x squared plus y squared. Right, it's this thing here, so it's that thing there. So now I'm going to have e to the power negative 4r squared times r dr d theta. Very, very, very simple. Again, because these integrals only have constant and boundaries, what you can actually do, you can just integrate them independently. So it's from 0 to pi. There's anything without this, so it's going to be d theta again, times from 0 to 1 e to the power negative 4r squared times r dr. And then to solve this here, I'm going to use the u sub. You are going to use the u sub to complete this problem. Right. 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 Let us look at another thing. Number 3. A region is bounded by x squared plus y squared is equals to 5. Y is equals to 1 over 3. 1 over root x, 1 over 3x, like that. And x is equals to 0. Find the volume. How will you find your volume? So you need to draw this. First, you need to draw a cycle. That is cycle. That is a perfect cycle for me. That's a perfect cycle for me, right? The next one, it is y is equals to 1 over root 3x. So that line, it's somewhere here. Right, that is a line there. And then the last one, it is x is equals to 0. So that one. So when you see this, you see this, we actually have two regions which are bounded. We actually have two regions because actually everything here is bounded, but the one which is bounded by the most, it is this one and that one. That one is bounded by the most. So to integrate this, I'm actually going to say two times an integral, because we have two regions which are going to be the same, r dr d theta. Now where's your r starting? Your r starts from here to that point, which means it's going to be 0 to root 5, which is the radius of a cycle. Your theta, this is your region you are focusing on. That is the region that you're focusing on. And your region starts at that particular angle. We know that the maximum value of this region is pi over 2. Now, how would you get that particular value of theta? We are going to say theta is the arctangent of 1 over root 3. Right, what is the answer to this? So if you say shift arctangent 1 divided by root 3, what do you get? We get pi over 6. Yes, it's pi over 6. So it's pi over 6. So your minimum angle here, it's just pi over 6. Pi over 6, that's all. So doing your integrals here, I'm going to integrate from pi over 6 to pi over 2 d theta times an integral from 0 to root 5 of r dr, which is something like pi over 2 minus pi over 6 times 1 over 2 times 5, which is 3, which is 2 pi over 6 times 5 over 2, which is 5 pi over 6. So that is the volume times 2. I just forgot about the 2. Times 2, it's how many times 2 goes here? 3 times. So it's going to be 5 pi over 3. So that is going to be the volume, right? Next one, I'm just going to draw the region. What is this number? Number 4. Now if you integrate 1 over the square root of x squared plus y squared r dA for r, just going to give you the region here. The region that we are talking about, it is this one. So that one is the region. We are talking about that region, and the equation outside, it is x squared plus y squared is equals to 25. The equation inside, it's x squared plus y squared is equals to 1. Now, how would you find the the polar coordinates form of this. So first of all, we need to rearrange this. A double integral 1 over square root of r squared times r dr d theta, right? We know that x squared plus y squared is r squared. Now your theta will start from here to there, your theta, which means it's from 0 to pi over 2. Now where is your r starting? Your r, I wrote it here. Yeah, it's the radius. I didn't write the radius thing. Your radius, it is the value between the region and the outmost function, and your region starts here to there. So your r for that one is what? The square root of this number, which is 1, and the r which is there, it's the square root of that number, which is 5. And then integrate this. D theta times 1/5 dr. So it's pi over 2 times 5 minus 1, which is 2 pi. Right, so this is actually polar coordinates. I'm only going to explain these few examples. The most convenient ones, the last ones, that whenever the region is between two cycles, you always start with the smaller cycle and end with the bigger cycle. Your value of r will depend on them. So there's nothing, if there's nothing to share, see you next time.